Okay, let's get into Unit 8, Motivation and Emotion. This chapter is about what motivates and drives, specifically human behavior, but sometimes animal behavior in some instances also. But basically it is the driving force behind the behaviors that we do, the choices that we make, or even the instinctive things that we don't necessarily choose. So you have the psychological motivation for behaviors, you have the biological or instinctive motivation for behaviors, and then you have things like emotional or achievement or even sexual motivation, things like that. So I like this chart when you look at the homeostasis balance. That term homeostasis comes in this chapter, and it's this idea of an internal constant state. And we look back at the hypothalamus and the blood chemistry and what the purpose of the hypothalamus is, and that is to constantly evaluate what chemicals are in short supply and what chemicals are in excess. And basically you have this endocrine process of homeostasis, sympathetic and parasympathetic balance that just continues. When we perceive a threat, we see an increase in certain chemicals like adrenaline, and then once we've burned enough energy, the brain realizes that, the hypothalamus realizes that, and then we go through this exhaustion phase where we get a parasympathetic response to that to go back to our homeostasis balance. And so our chemical constant struggle is to maintain this constant state. So between the instincts and drives that we have, and the incentives are things that we're running after, things that we want, foods that we want, whether it's because we're hungry or it's because it tastes good and we just desire it. So this dopamine motivation and drive, amygdala fears and things like that. So when we look at drive reduction theory, if you look at the top chart there, we talked about this in one of the videos I posted before about the difference between the need, the drive, and the drive reducing behavior. So you have biological and physiological needs. You need nutrients. You don't necessarily need food. You need nutrients. You need water. You need sleep. And so when you have a biological need, you get what's called a drive, and those are chemical. That's a homeostasis, let's say a homeostatic process that's driven by the hypothalamus. So think H for hypothalamus, H for homeostasis, and that drive is basically something like thirst or hunger or sexual arousal, and hopefully it is a motivating drive so that you will participate in a drive reducing behavior. So if you were dehydrated, your need would be water, your drive would be thirst, and the drive reducing behavior would be to drink. So you would participate in a drive reducing behavior which was motivated by a drive, and that drive is based around a physiological need. So that's the motivation and drive reduction behavior, and it's about homeostasis. So then we get into things like stress and the optimal levels of stress. The Yerkes-Dodson Law is something that's very interesting to me, because I think we can all sort of connect with this or empathize with this, that there's an optimal level of stress that you need in order to perform and pay attention for your optimal performance level. So for instance, if you look at this curve, you have, if the stress level is too low, you get apathy, you get boredom, you get exhaustion, or somebody is tired. In other words, they're not focused on the task at hand, they're not engaged. But as that stimulation level increases, that stress level increases, you get this nice balance in the middle where your performance level actually peaks at its highest. But then it starts to drop as your minimal optimal levels of stress turn into too much stress, anxiety, even panic. Then you start to get too stressed, too restless, too anxious, and it actually, you see a decrease in the performance level. In fact, the more that stress that you have, or the more that stress increases with a particular behavior, the worse the performance level is as the stress level becomes too high. So that's the basic explanation of Yerkes-Dodson, but there's also this comparative bell curves here. When you look at things like difficult tasks, to take your Yerkes-Dodson even deeper, if something is very difficult for us to do, it doesn't take very much stress level or stress arousal to drop our performance. So if something is very difficult, say like playing an instrument in public. If you have a fear of public speaking, your stress level is going to be high, and if it's a difficult thing for you to play that instrument, your performance level is not going to be very good. It's going to suffer as a result of that. Whereas if you look at the other curve, the curve on the right, which is the red one, if it's an easy task, something that comes easy to us, it actually requires more stress for us to perform at a higher level, right? That could be something like that social facilitation, when we do well because other people are watching or other people are paying attention. So when you really kind of take these two curves apart, they make a lot of sense. The more difficult a task is, the worse or more detrimental, we'll say, that stress has on the performance of that task. But the easier the task is, you actually need a higher level of stress in order to perform at a better level, because you would be bored, right? The task comes too easily. So when you look at it another way, if it requires too much effortful processing, it doesn't require very much stress. And if it doesn't require very much effortful processing, if it's a muscle memory habit that you have, it might require a little bit of stress for you to actually peak in your performance, which is why we can explain things like people putting off their studying to the last minute, or people who wait to write their essays or to do their projects, because that optimal level of stress actually makes them motivated and attentive enough to perform at a high level. They're not bored, they're not distracted, they're not apathetic towards the task. And that's the Yerkes-Dodson Law. Let's get into Maslow, the humanist. Abraham Maslow is probably one of the more famous people, along with Sigmund Freud and maybe Piaget, in this entire textbook, and that's because his theories of a hierarchy of needs or a hierarchy of motives have really been used in a lot of different subject matters. You see it in human growth and development. You see it in philosophy. This existential discussion, you see Maslow used to explain poverty and need, privilege, and things like that. But basically what Maslow was trying to theorize is that there is an increasing level of psychological need, and that all of your needs have to be met in order for you to progress to the next level or the next rung. So he kind of put them as a pyramid, because the bottom of the pyramid is the most physiological related things: food, water, shelter, and then your needs become decreasingly physiological and increasingly more psychological in nature. So once your basic needs are met, then you have belongingness, you have love, you have acceptance, and the goal is to become self-actualized, which really is just a fancy way of saying that you meet your potential as a person. So Maslow basically would look at a patient who had anxiety or stress or depression or suffered from various psychological illnesses, and he might say the source of their unhappiness or the source of their anxiety or the source of their depression lies somewhere in a need that was never met. They never self-actualized. They never were fulfilled. They didn't meet their let's say their potential as a human being. So when you look at them specifically in the hierarchy of needs, your most basic needs must be satisfied first before you can move up the pyramid to more psychological needs. So you start at the bottom with physiological needs, and again, it's going to be difficult on an AP exam to try to remember the exact order, but you just need to kind of pause and think about it from more general terms. The more physiological and immediate that the needs are, the more immediate they're going to be on the pyramid. So in other words, your physiological needs are going to come first. If you don't have adequate food or water supply, then you're not really going to be focusing on the task of reaching your full potential as a person, or your self-esteem is not going to be your most immediate thought. It's going to be where your next meal is coming from, or where you're going to get water, right? Just like if you were drowning in the ocean, you're not going to be thinking about the future. You're going to be focusing on the most immediate thing, which is survival in that moment. So your survival physiological needs are always going to come early in the pyramid, and then they're going to become increasingly more psychological. So after you get an adequate food supply and you're not thirsty, then the next level on the pyramid is the need to feel safe. Right, so people have a concern that they're not in a safe home, or they don't know where they're going to sleep, or they don't know what the routine is like. So that predictability, that safety, physical safety, emotional safety, that they're not being abused, that they're not going to be harmed, or they're not going to be hurt, and they're not going to be, let's say attacked and robbed in their neighborhood or something like that. So that's an immediate need that people would be focused on if they were unsafe. That would become the most prominent thing in their thought processes. And once you feel safe, once you feel a predictable world that you can take some things for granted, then there's this need to belong, the need to feel loved, and the need to love other people, the need to be accepted by your peers, but more importantly to be accepted by your family members, that you are not lonely, that you are not separated, that you have people, basically. And then once that belongingness need is met, Maslow says that people seek self-esteem. You look for achievement, you look for competence, you look for independence, you look for recognition and respect. You have this sense of self-pride in your abilities, that you have some esteem. Then you look to self-actualize, which is where you try to reach your potential as a person, your contribution to the world, and doing the things that you're uniquely capable of to live a fulfilling life. And then Maslow takes it a step further than that. He believes that once people are self-actualized, they actually become very aware, consciously aware of the people around them that are somewhere else on the needs pyramid, and they start to self-transcend. So people who have self-actualized in their own needs now become motivated to help others. So they find meaning and fulfillment when they help other people. They become charitable, or they volunteer, or they teach, or they try to help people meet their own personal needs. They give back to their communities, or they try to take up a cause, right? Those are things that people do that transcends beyond their own needs, and in theory, Maslow explains that because they've met all of their needs, and so now their need becomes to help and reach out beyond their own self. So that's self-transcendence, and that's Maslow. Now if we get into the more biological or physiological side of things, this would be at the very bottom of Maslow's pyramid. We get the endocrine process of how hunger, let's say drive reduction theory, actually works. Now keep in mind that the hypothalamus is constantly evaluating the bloodstream to see which levels are in short supply and which levels of chemicals are in excess. And if there's too much of a chemical, then the pituitary gland will release a different chemical, and that chemical will get into the bloodstream, and it will cause or it will inhibit a process. And so basically what you have is a chemical imbalance, which leads to the drive of hunger. That's how your brain knows that you are short of nutrients. Your brain doesn't know that your stomach is empty. It knows that the bloodstream is in short supply of various chemicals. So that's how the hypothalamus is involved in your hunger processes. It's also how the hypothalamus controls thirst. The hypothalamus is involved in sexual arousal. So these are all homeostatic processes. So glucose and hormone levels fluctuate, and they tell us when to start or stop eating, and this affects our drive of hunger. So the need for nutrients creates the drive, which is hunger, which is obviously the drive-reducing behavior that would be eating. So before you eat, your leptin levels drop, your ghrelin levels increase, peptide levels drop, double Y especially, and the way that you can remember the difference in these chemicals, there's some mnemonics. Ghrelin kind of sounds like the word growling, so if you have a nice southern drawl anyway, so if your stomach is growling, that means you're hungry. So basically you think if your stomach is growling sounds like ghrelin, so you kind of put a southern twang on it and say their stomach is ghrelin. So you have ghrelin, which is the chemical that is released when the stomach is empty, when your glucose levels are low, we'll say. Not so much that your stomach is empty, but there's a depletion of glucose in the bloodstream. So when the hypothalamus detects ghrelin, essentially, which is produced by the gut, then essentially it sends a response, and that response will kick into something from the brain, which is a neurotransmitter, and that's orexin. So if you think of the term orexin, then you have what? Anorexia, which is a eating disorder, meaning not eating or to stop eating. So that would be the opposite of orexin. If an means to not or non. So even though it's not exactly the same thing, that's a good way to remember what orexin is. Orexin is produced by the pituitary gland, whereas leptin, ghrelin, and those peptides are produced in the gut. So the difference is any chemical that's in the bloodstream that's produced by an organ is called a hormone, and any chemical that's produced in the brain is called a neurotransmitter. So neurotransmitters are the brain function, where the hormones are the body function, the gut function, or in this case it would be the gut function or the endocrine function in whatever gland or organ is involved. So in this case we're talking about hunger. So we have leptin levels that drop, ghrelin levels increase, and the hypothalamus can detect those ghrelin levels, and it releases orexin, which causes your leptin levels to rise, your ghrelin levels to decrease once you have enough glucose in your bloodstream, we'll say. And then essentially that is a homeostatic process which basically tells the gut to stop producing those hormones so that you no longer feel hungry, you feel satisfied. Eating disorders are psychological. They're not necessarily biological. They're not necessarily based on something that's genetic. It is a psychological disorder. It's a disorder of the mind. So it's essentially a delusion. When people who they think they are unhealthy or they think they are too fat, they think that and that's usually the case. You can have eating disorders where people think they are too skinny, or other eating disorders where people binge eat. But in this case, if you look at bulimia and anorexia, that is a disorder of the mind where people have a perception problem. And again, we know just like addictions, if you have a chemical imbalance, you need chemicals to balance that out. But if you have a psychological imbalance or a psychological disorder, you need therapy to fight that. So most people that have eating disorders would need some type of therapy to overcome that, and it's usually a tough, difficult, ongoing process. So anorexia nervosa is one type of psychological disorder that is in the DSM-5. Anorexia can be diagnosed by a psychiatrist or a psychologist, and that's when someone continues to starve themselves and deprive their body of much needed nutrients even though they are well underweight. Bulimia would be another form of an eating disorder where you allow yourself to eat, but then you somehow purge the food, whether it's throwing it up or using laxatives. But it's eating and then purging the food after that. Binge eating disorder obviously would be the opposite of that. Those are people who they tend to essentially they load a bunch of empty calories, and that's usually because of sadness or body image issues or stress or whatever the case may be. They turn to food as a coping mechanism, and they eat a lot of foods, and then they feel guilty that they ate a bunch of food, and it causes image issues, it causes shame, it can cause depression. So that's another psychological disorder. The term obesity is a medical term. It's a term that refers to having a body mass index of 30 or higher. So body mass index is not exactly the height and weight chart. A lot of people have kind of pointed that the BMI is a problematic number, but the BMI is actually something that is physically calculable in the tissue. They can do a clamp on your tricep, or they can do an idea of the body fat content. There are different body types. Some nutritionists predict that or estimate that there are 3 different specific body types. Some people say there are as many as 5, but there are different body types. So your height and your weight don't necessarily tell the whole story, but your BMI does not lie. If your body mass index is 30 or higher, then you are clinically obese. And once you get above that, then you are morbidly obese. So you can't just go by the charts with your height and weight, because muscle is very dense. Muscle, essentially the same fiber amount of muscle weighs 10% more than the same amount of fat. So muscle is heavy, and so on the scale you're going to show up, if you follow those charts, as being obese or morbidly obese, but you can't go with the weight and the number on a scale. You have to go with your body mass index. And then this homeostatic term of set point. The set point is the body type's easily maintained preferable weight. So basically your body is constantly fighting to stay at a weight, and it's whatever its genetic set point is. And so sometimes you might be trying to put on weight for athletic purposes, but you're fighting against your body's natural set point, or sometimes you're trying to lose weight beyond what your body's set point is, and it's going to be very difficult. You're fighting the battle of your DNA, you're fighting against your genetics, you're fighting against your homeostasis, you're fighting against the hypothalamus, and it's a difficult thing to do. So one of the things to do that in healthy nutrition and exercise is to learn your body type, to learn your body mass index, and to learn your set point. And then you get into things like your resting metabolic rates and things like that. So let's get into sexual motivation. The first thing is the sexual response cycle. This is Masters and Johnson's groundbreaking study that they did in the 50s and 60s. The 40 studies that you did on that, probably the most awkward 40 studies there is. But basically that was the biological study where they successfully calculated, we'll say, or plotted is a better way to put it, the 4 stages of the sexual response cycle. Essentially, regardless of physiological things, regardless of orientation, regardless of age, regardless of, this is basically this is a biological homeostasis process from excitement, plateau, orgasm, and resolution, and then you get refractory periods in men and some women before you can go through the sexual response cycle again. So again, this was a very large sample size. There was certainly some critique because you get a type of bias that's called volunteerism bias. These are people that are willing to subject themselves to such a difficult, we'll say, difficult study. Basically, you're being very vulnerable for scientific purposes, which would affect the results of the study. So you get some bias with the type of people that would volunteer for such a study, being secure in their sexuality and things like that. But even when replicated, even when accounting for age and accounting for sexual orientation, you get the same 4 phases throughout the sexual response cycle, and it is genetic. You can measure it with skin conductance, and you can measure it with blood pressure and things like that. So in the excitement phase, you get the genital blood flow and lubrication. You get sympathetic arousal and breathing and pulse. In the plateau phase, you reach the peak of excitement and your body begins to prepare for sexual stimulation. Orgasm would be the contraction of muscles, and then the release of the fluids, whether it be for male or female. In orgasm, there is discharge, and then you have resolution, and that's in the enlarging of the genitals as the blood is released, and then everything goes back to homeostasis or homeostatic normal as you go through a refractory phase. Refractory period, we'll say. Other sexual stimulation has to do with things like primary sex organs versus secondary sex organs. Primary sex organs, if you get asked that on an AP exam, are the things that are directly involved in reproduction. So those are going to be testes, ovaries, and genitalia. Secondary sex organs are going to be things like breast tissue. They're going to be things like facial hair, whatever is hormonal from a biological male or a biological female. That's going to be based on their homeostasis because of puberty. So primary sex organs are directly involved in reproduction. Secondary sex organs like breast tissue and things like that, the Adam's apple for a male, those are going to be things that are the result of hormones, hormonal things. So between XX and XY, when it comes to your genetic code, it's determined at birth whether you are male or female, man or woman, and then basically if you have testes as a male, you will produce your primary sex hormone, which is testosterone. Females do also produce testosterone and respond to testosterone. Males also produce estrogens, but not in the same levels because of their sex organs. So the testes being the testosterone factories and the ovaries being the estrogen factories. Psychologically, you can respond to external and imagined stimuli. Again, this is something that separates humans that's unique, and Virginia Johnson and William Masters found this in their study, that people could be sexually stimulated by thoughts, memories, phrases, and wording, so not just physical touch and not just sight. So the most common thing that's answered in studies when people say what is which of the 5 senses is the most sexually stimulating, people would say sight, or people would say touch. But you can also think psychologically about things that will cause the excitement phase of the sexual response cycle. So it can be real or imagined, but it's essentially part of the brain. So when you think about if it's a thought process, it's going to be in the frontal lobe, in the prefrontal cortex. If it is something that you see that is sexually arousing or sexually stimulating, that's going to be part of the hypothalamus. There's a nucleus in the hypothalamus that's known as the septal region, which involves the visual cortex, and that's for sexual stimulation based on things that you see. So there are different ways to become sexually aroused and to respond sexually, and certainly humans in some primates are much more sexually expansive in the ways that they can experience sexual arousal. Then you get into things that are more psychological and physiological than, say, reproductive. You have things like the orientation of one's sexuality, which is simply put means the gender that they are physically attracted to in the sexual response cycle. You can be heterosexual, you can be homosexual, or you can be somewhere in between, whether it's bisexual. The biological evidence of differences between hetero and homosexuals are things like hypothalamus changes in males that are same-sex attracted, meaning they're attracted to other males sexually, females that are same-sex attracted. So you have hypothalamus changes there. When they are in animal studies, you have injections of estrogens in the male fetal tissue of sheep is one study which caused same-sex attraction and same-sex initiation, which did not seem to be of the alpha dominance reality, because that would be a confounding variable, obviously. You have cultural influences in human sexuality, and then there's definitely environmental influences. So again, something I mentioned in class months ago that we have to be careful with sexual orientation is that when people ask whether or not it is nature or nurture, it's probably the wrong question. Human sexuality is very rigid. It's very patterned into who we are. But whether or not it is genetically encoded into us, or whether or not it is environmentally stimulated, really probably doesn't matter, because it is something that is rigidly patterned in humans. So the need to belong, this would be one of those like incentives. It's more psychological, but it's not unique to humans. You have animals that are pack animals. You have animals that it's a function of survival for them to exist in a social group. So the need to belong affects our emotions. We have emotional rejection, depression and sadness that comes from being rejected. We have atypical behaviors that people make in the way they dress and how they act, the things they say, and the rejection of even family members so that they will be accepted by a group. And study after study shows this, but you can see this on a day-to-day basis on a high school campus. It's probably not that hard or that much of a stretch to think that people do irrational things in the attempt to belong to a group and to feel connected, which is one of Maslow's hierarchy of needs, is that belongingness need. Then we get into theories of emotion, which we really could go into a lot of depth about the theories of emotion, but you can watch my video about that where I specifically explain the 3 different theories if you want some more details on this. But suffice it to say that there are 3 sort of competing theories of how the order of operations works when it comes to creating an emotional response. So for instance, one theory, the James Lang theory, which is William James and his a later replication of his study kind of gets lumped in with his because it agreed with him. The idea that you get a physiological response first, and then your brain kind of tags that as an emotion. Right, so there's a stimuli. In this case, it's a threat. The car is coming at us. Our heart starts pounding, and then we experience what we perceive to be fear. In the Cannon-Bard theory, there's no separation. Cannon and Bard have this theory that you cannot differentiate in the human mind at what point the physiological symptom starts and the emotion is experienced. So the way to look at the Cannon-Bard theory, those 2 things happen simultaneously. As the car is driving at you and you realize you're in danger, your heart starts pounding at the exact instant that you realize that you are afraid. And that cannonball theory that I put in quotes there is this idea that if you imagine two cannons firing simultaneously. That will help you remember that the cannon barred theory is that these two factors of emotion happen at the exact same time. And then we have the two-factor theory, which is the Schachter-Singer theory, and basically this adds in a secondary factor of the ability to cognitively understand. And so this is the most complex of the three. It's probably the most accurate of the three also, and it's the idea that you do get this simultaneous feeling, this physiological emotion of fear. We don't necessarily have to explain that we are afraid. We feel afraid, and we know we're afraid, and that's at the same time that our heart is beating and our pupils are dilating. But then Schachter and Singer take it to another level. There's a second tier to that, and that's this idea that your fear is actually is your brain's construct. It's an understanding. It's a label. So your brain takes what's happening to you, and it creates a title for it. It creates a label for it. So that's the cognitive label, which is the second of those factors. So again, if you wanted to go into some more depth with that and get some more examples, you can watch the other video, which is on my YouTube channel, about theories of emotion. And then, of course, we've gone over sympathetic versus parasympathetic arousal in a previous chapter. This was in chapter 3. But the fight or flight response is your brain's response to a threat. And when you perceive a threat, all of your homeostatic processes start to kick into gear. You get the sympathetic nerves. So in these nerve pathways, you have sympathetic nerves, and then you have parasympathetic nerves, which are connected to those neurons. And so you have, in the same pathway, you have some nerves that have receptor sites for things like adrenaline, and then you have other nerves that have receptor sites for things that counteract adrenaline. And so these are all chemicals that are processed in the bloodstream. The sympathetic nerves are activated much more quickly. So you realize that there is a threat, and you either react as a fight response or you react to flee from that very quickly. Your adrenaline takes seconds to cycle through your bloodstream because your heart rate is massively increased, and it actually takes a lot longer to calm you back down. And that is because once those calming chemicals get released into your bloodstream, they still have to circulate through the blood, and you still have to metabolize the adrenaline, you have to metabolize the glucose, and you have to metabolize some of these other stimulating excitatory neurons. So if you look at the chart there on the right, you can see kind of this ideology of where in the spine these messages are sent, but also this idea that these two pathways are connected. You have sympathetic nerves which are connected to parasympathetic nerves, and this is everything from fight or flight to, as you can see at the bottom, you have the sexual response cycle, which is also a sympathetic nervous response. So whether it's a good emotion or a bad emotion, it is a heightened emotion. It's what we call a positive emotion. It's a hot emotional state is what it is, and you need a calming reaction to that. So whether it's panic, stress, cortisol from a threat to you, a perceived threat or a real threat, so you're in danger, or you're about to be in an accident, or you slip and fall, or you're afraid that someone is going to attack you, or you are just sexually aroused. All of those things process in the body the same way. The difference is the way that your brain perceives the emotion. Experienced emotion, again, is something that there's a lot of overlap here. It takes some experience, and going back to the Schachter-Singer two-factor theory, your cognitive ability to understand your situation gives a lot of context for your emotion. So for instance, if we buy into this idea here that there are 10 basic emotions, and there may be more than that, but some psychologists believe there are 10. So if the basic emotional range that you have ranges from joy to excitement, surprise, sadness, anger, disgust, contempt, fear, shame, and guilt, a child, an infant, a baby is not going to be able to cognitively understand the difference between shame or guilt, or disgust or anger, joy or excitement. And even we at times don't recognize the difference between the two. But that's why the cognitive side of how you experience your emotion is so important, because your understanding of the situation that you're in gives context to what emotion you're feeling. And that's why the Schachter-Singer two-factor theory is probably the most accurate one. Take, for instance, fear. Fear is almost always learned. There are very few things that are genetically cause fear in us. Things like snakes or moving animals in the woods. Those things are probably genetic in our DNA, but other things are learned. Things that we're afraid of, the panic that we have, the stress that we have, the anxiety of not getting into colleges, or boyfriends or girlfriends breaking up with us, or parents moving us to new towns, or where are we going to go to college. Those are all learned fears, right? Those are all things that are not genetically life-threatening, but they are cortisol-inducing nonetheless. So for instance, it's kind of comical, in the most widely done study of survey information where people are asked to list and rank their fears, the number one reported fear of the people in this survey, of more than tens of thousands of people, was public speaking, and number two was dying. So according to those results, people are more afraid of speaking in public than they are of actually dying, which obviously is probably not the case. So our perceived and experienced emotions, we make them more intense than they really are, but they're learned. Anger can be harmful. It can be helpful. People have anger outbursts. So in other words, rage and anger are different things, but they're also probably both biological. They're probably normal. They are physiological emotions that you experience with chemicals in the brain and chemicals in the body. The anger management problem comes with the prolonged uncontrollable anger, things like that. Happiness, you get things like the feel good, do good phenomenon, right? You feel good, so you go out and you go plant a tree, or you go help somebody, you pick a kid up who fell down and is crying, or you help somebody unpack their groceries, you do something that makes you feel good. You are motivated for good deeds when you're in a good mood. You get adaptation level phenomenon, basically that we become accustomed to our standard of living, and in fact we don't really start getting disappointed or depressed until we start comparing ourselves to other people. But that works in reverse. If you are feeling bad and terrible about your station in life, you can go visit a population of people that has much less than you do, and it will give you perspective. And so that adaptation level phenomenon is this idea that we look at people 100 years ago, or we look at people in developing countries now, and we just can't imagine that people live like that. Well, that's because that's not our normal. Well, for them, that is their normal. It would be hard for us to imagine life 100 years ago, or life in a developing country today. That's because of adaptation level phenomenon. We get accustomed to our standard of living, and that's what we expect, and that's what we want, and that's what makes us feel normal and happy. Relative deprivation is this idea that we are only deprived relative to other people. So when we look at what other people have, we get this Instagram jealousy and things like that. So that's relative deprivation. We're not really deprived. No one in America, even the poorest people in America who don't have electricity and running water, are relatively deprived when compared to some of the circumstances that other peoples have had, other people groups, or people in the world today, and certainly people in the past. We get general adaptation syndrome. This is from a psychologist named Hans Selye. You can see Selye down at the bottom explaining the endocrine process of stress. And stress, we know, is a chemical called cortisol. Well, I don't know why I enunciated it like that. It's called cortisol. But cortisol is released as a perceived threat happens. But Selye's theory is pretty simple. It looks complicated because it has stages, but it's pretty simple. The idea is this: when we perceive a threat, we go through 3 stages to respond to that threat. So basically, stress happens in 3 stages. First, the alarm stage. That's where we become aware of the perceived threat. That's when the stressor happens. From there, we get sympathetic nervous arousal. And what happens is your body is preparing you to resist the stress. That's the fight. That's the flee. But eventually, you burn so much energy in that resistance phase that as that stress is still there, that stressor is still there, you start to go through the exhaustion stage, and you really just you stop resisting the stress. And this is why you see people who go from anxiety to depression. The depression is the exhaustion stage. They don't have the physiological energy to continue to care and stress and ruminate about the same things, and they almost essentially give up because their body is crashing. So you have the alarm where you become aware of the stressor, you have resistance where your body is being prepared to fight or flee against a stressor, and then you have the exhaustion stage when you run out of energy. So we look at GAS, or the General Adaptation Syndrome. One of the mnemonics I saw, think GAS ARE, alarm, reaction, resistance, exhaustion. I don't know if that's helpful or not, but just imagine that you perceive the threat, you fight the threat, and then you become exhausted. Coronary heart disease is what happens when our heart breaks down from overuse. Increased sympathetic nervous arousal, right? This is our response to stressors. Two types of personality types. It's really a lot more complex than that. It's more like Myers-Briggs or the Big Five personality traits. But if you break people down into two stressor types, you have type A people and you have type B people. And type A people are very aggressive. So think of the A's: angry, aggressive, and you can imagine the other A. And then type B, think like beach bum, somebody who's calm and relaxed and chill. Then you have things in your stress response system, like your body's ability to fight infections and things like that because of lymphocytes. You have B lymphocytes, and those are to fight bacteria and fight infections. And then you have T lymphocytes, and those are from the thymus, and that's for foreign toxins and cancerous growth, viruses, and things like that. So think B for bacteria, B for bone marrow, and think T for the thymus, and fighting things like viruses and foreign substances. And those all have to stay in a happy balance whenever you take drugs that deplete your immune system, or whenever you don't eat correctly or you don't get enough sleep over a prolonged period of time. You're changing the chemical makeup, and you're making homeostasis difficult, and it makes it harder for you to fight infections and diseases. Stress lowers your body's immune system, as we just talked about, and it opens you up to disease. So that's chapter 8. Next we'll get into chapter 9, or unit 9, which is the Piaget chapter. This is developmental psychology, so the two biggest people we'll go over will be Piaget and will be Erik Erikson, and then there'll be some Freud in there as well.